Students, welcome to the next part of our chapter electricity. We are starting with the physical quantity electric work. Electric work is said to be done when electric charge flows through a conductor at some potential difference. From the definition of electric potential difference, we know that potential difference WV is equal to work done per unit charge. So in this case, electrical work done, it will be equal to charge into the potential difference. From the by definition of the current, I is equal to Q by T. What will be Q? Q will be equal to IT. Therefore, what is the expression for electrical work? It will be equal to VI into T. This is one expression for the electric work. Also, by Ohm's law, V is equal to IR. So if we use this value of V in the first equation, W will be equal to I square R into T. This is the second equation for calculating the work done. We also call this equation as Joule's law of heating effect. Now again, if we use Ohm's law, V is equal to IR. So what will be the value of I? I will be equal to V by R. So if we use this thing in the first equation, so first we have substituted the value of V. Now we are substituting the value of I in the first equation. W will be equal to V square R over V square T over R. This will be the third equation for the calculation of electric work. Now unit of electric work, we know that W is equal to charge into voltage. So if charge is equal to 1 coulomb, potential difference is 1 volt, then the unit of electric work will be 1 joule. That is, when 1 coulomb of charge is flowing through a conductor under a potential difference of 1 volt, then electric work done will be equal to 1 joule. Next, power. Electric power is the time rate of doing electric work. That is, power is equal to electric work divided by time taken to do that work. So from first, second and third equation, power is equal to work over time, which will be equal to product of voltage and current. This is fourth equation. From second equation, power again is work done over time, which will be equal to I square into R. This is fifth equation. From third equation, power, which is work over time, it will be equal to V square over R. This is the sixth equation. So using first, second and third equation, we can calculate electric work, and using 4, 5 and 6, we can calculate the electric power. Next is the unit of electrical power. Power normally is measured as the product of voltage and current. We know that SI system, voltage has the SI unit 1 volt, current has the SI unit 1 ampere. So unit of power is 1 volt into 1 ampere, which is 1 volt ampere, which is known as the 1 watt. So power of an appliance will be 1 watt if 1 ampere of current is flowing through it under a potential difference of 1 volt. Commercial unit of electric energy. For business purposes, commercial unit of electrical energy is used. We know that power is equal to work into work over time, so work will be equal to power into time. So if we take power in the unit of watt and time is taken in the unit of hour, then the commercial unit of electrical energy becomes 1 watt hour. But 1 watt hour is very small unit, so bigger unit of electrical energy that is used is known as 1 kilowatt hour. And we already know 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joule, or 3.6 megajoule. Next, an important thing, power rating of an appliance. Whenever we buy any appliance, every appliance has its power rating marked on its body as well as on the packaging material. What is power rating of an appliance? Two physical quantities are mentioned on the body of the appliance. One is the operating voltage of the appliance, at which voltage it will be operating properly, and second, the power which will be consumed by the appliance when operating at that particular voltage. For example, for a bulb, power rating can be given as 60 watt hyphen 220 volt, which means that when this bulb will operate at a particular operating voltage of 220 volt, it is going to consume a power of 60 watt. For a TV, if it's mentioned as 80 watt 220 volt, it means when power operating voltage of the TV will be 220 volt, it is going to consume an electrical power of 80 watt. But one thing you have to remember, that if operating voltage changes, then the power consumed by the appliance will also change accordingly. So if bulb is not operating at 220 volt, but if it is operating at greater voltage, say 250 volt, then it will also consume power greater than 60 watt. And if it is operating at a voltage less than 220 volt, say for example 200 volt, then the power consumed by the appliance will also be less than 60 watt. So how much power exactly will be consumed, that will depend upon the operating voltage. Now, power rating of appliance is very important to us because it helps us to know two important physical characteristic properties of the appliance. First of which is the resistance of the appliance. For example, from the power rating of a bulb, we can find its resistance. We know that power is equal to V square over R. Power is given by equation V square over R. So R, it will be V square divided by P. So for this bulb 60 watt 220 volt, its resistance will be 220 square divided by 60, which will be equal to 806.7 ohm. This is the resistance of the filament of the bulb when the bulb will not be working. Normally we call this resistance as the cold resistance. That means when the bulb is not working, resistance filament is cold at a room temperature. But when the same bulb will be operating, it will be switched on. We know that it will be producing a lot of heat energy, and we already know resistance of the material rises with the temperature. So when the bulb will be operating, its resistance of the filament, it will be greater than this value, that is 806.7 ohm. The second thing we can find from the power rating is the safe limit of the current. That means the maximum current up to which the bulb is going to operate without any problem. We know that power is equal to voltage into current. So current, it will be equal to power divided by voltage. So bulb power is 60 watt operating at 220 volt. So the safe limit of the current is equal to 0.28 ampere. This means that this is the maximum current which we can pass from the bulb without damaging the filament of the bulb. This is called the safe limit of the current. So if a current up to 0.28 ampere is passing through the filament of the bulb, the filament of the bulb will be producing the sufficient amount of heat energy and light energy such that no harm will be done to the filament. But if a current greater than 0.28 ampere is passing through it, then the filament will start producing more amount of heat energy, which will increase the temperature of the filament, and it may reach to its melting point. So at that stage, the filament will break up and the bulb will stop working. So every device has a certain value of a safe limit of the current up to which the device is going to, or appliance is going to work properly. Any current greater than that safe limit is going to harm the appliance. Next is household consumption of electrical energy. Whenever we calculate household consumption of electrical energy, for example, monthly bill for the consumption of energy, this energy is always calculated in the unit of kilowatt hour, that is in commercial unit of electrical energy. So for calculating the consumption in kilowatt hour, what we do, we always take the power of the appliances in kilowatt, we multiply it with the time for which they will be working in hour, and then divide it by 1000 to get electrical energy consumed in kilowatt hour. For example, for example, we are given a heater. Suppose the resistance of the heater is equal to 50 ohm, and it is operating on a voltage of 200 volt, and each day it is operating for a time of 4 hours. So in this case, power of the heater, it will be V square over R, 200 square divided by 50, which is 800 watt, which is equivalent to 0.8 kilowatt. Therefore, energy consumed in one day, it will be equal to power into time, 0.8 into 4, divided, it will be 3.2 kilowatt hour. For 1 month, how much it will be? 3.2 into 30, that will be equal to 96 kilowatt hour. That means how many units of energy have been burned? 96 units. Therefore, what will be the monthly cost? It will be number of units consumed multiplied by rate of electricity. Suppose rate of electricity is 2 rupees per unit, then it will be equal to 192 rupees. So in this way we can calculate the monthly consumption of electrical energy. Thank you.